All right, we are on the arithmetic sequence day 2. In this video, we will solve 5 problems, the last 5 problems of this arithmetic sequence. Let's start with this first question. In an arithmetic sequence, the first term is 8, the second term is 5. Find out the common difference. It is a very simple question because you know the first two terms, but you need to write down some working because you will not get just writing the difference over there. So your first term is u1 is equal to 8 and second term u2 is equal to 5. Therefore difference is equal to u2 minus u1, which is 5 minus 8, which is minus 3. B part. Find the 10th term, u10. Recall the formula of un is equal to u1 plus n minus 1 times t. u10, that means n is equal to 10. u1, which we already know, 8. n is 10 minus 1 times t, which is minus 3. Use brackets because d value is negative. So u10 is equal to 8 plus 10 minus 1 is 9 times minus 3. So u10 is equal to 8 minus 27. So the final thing is u10 is equal to minus 19. C part. Find the sum of first 10 terms. Sum of first 10 terms, sum formula. Here we know the first term, we know the last term, so I'm using the second formula. You can use the first formula, you will get the same answer. So I'm using Sn is equal to n over 2 times u1 plus un. In this case, it is S10, n is 10, so 10 divided by 2, u1 is 8 and u10 is minus 10. S10 is equal to 10 divided by 2 is 5. 8 minus 10 is negative 2. So your final sum of first 10 terms is equal to minus 10. See the sequence, every next term is decreasing by 3. So that is why sum you are getting as a negative. So these are your final answers. D is minus 3. U10 is minus 19. And S10 is minus 10. We will move on the second sum. Write first 3 terms of this sequence un is equal to 3n. And clearly, you have to start with n is greater than or equal to 1. Why n cannot be 0? Because term number cannot be 0 term or negative number term. So we always start with the term number greater than or equal to 1, which is basically positive integers. There are conditions. N cannot be decimal. Term number cannot be decimal. Term number cannot be negative and term number cannot be 0. So let's start with the first part. un is equal to 3n. They want first 3 terms. So first they say n is greater than or equal to 1. So we will start with n is 1. Then n is 2. Then n is 3. So u1, so that means n is 1. So 3 times 1 is 3. u2, 3 times 2 is 6. u3, 3 times 3 is equal to 9. So your first three terms are 3, 6, 9. Find some first parts. This sigma notation is also considered as a summation. Summation of 3n from n is equal to 1 to n is equal to 20. And second, summation from 21, n is equal to 21 to 100 of same term 3n. Let's go one by one. We will first find out B1, summation from or sigma notation from n is equal to 1 to 20 of 3n. For that purpose, we need to understand what is sigma notation. I am writing as it is. N is equal to 1 to 20 of 3n. So we will start with n is equal to 1. So this becomes 3 times 1. Sigma notation means what? Between every next term, the sign is plus. After n is equal to 1 up to 20, the next term is coming as 2. 3 times 2. Then 3 times 3. You don't need to write down all terms. You just write down first 3 terms and then last term, that is 3 times 20. Write down that. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. And 3 times 20 is 60. Clearly, you can see this is an arithmetic sequence where your u1 is 3. Your difference is 6 minus 3, which is equal to 9 minus 6, which is equal to 3. And your last term, 60, is your 20th term. So u20 is equal to 60. Arithmetic sequence, we will use the formula S20 is equal to 20 over 2, which is n over 2, bracket u1 plus 3, u1 which is 3 plus u20 which is 60. 20 over 2 is 10. 3 plus 60 is 63. So the addition is 630. So sigma notation stands for addition of all particular term. Right now in this case is 3n by changing the value from 1 to 20. Again I repeat, you do not write down all those terms. You just write down first 3 term and last term. And check that whether the sequence is arithmetic or geometric, and according to that you need to apply the formula which is given in your formula booklet. Now the last part of this, summation from n is equal to 21 to 100 of 3n. This can be done if it is a paper 1. Then first you find out summation from you can take from n is equal to 1 to 100 of 3n minus summation from n is equal to 1 to 20 of 3n. As we know the second value is 630, you need to find out the first value. If it is a paper 1, it is very easy because you are taking the last term is what, 100. So again I am applying the same arithmetic formula for this, which is n over 2. In this case your n is total number of terms is 100. divided by 2 times u1, which is n is equal to 1, which is 3, and last term is 100 into 3 is what? 300, minus, we know this answer from the previous is 630, 100 over 2 is 50, and this is 303 minus 630. I repeat again, you don't need a calculator for this. 50 times 303. So last digit one of the number is 0. So keep it like this and you multiply this 5 to this. 5 times 3 is 15. Carry 1 and 5 times 3 is 15. So 15150 minus 630. If you are not comfortable, solve this. 15150 minus 630. Do proper simple subtraction. 0, 2, 5, carry 1, 4, 14520. This is what? This part. Next question. Now, instead of a traditional simple first term, second term, they have given the diagram. Read this question carefully. Consider the following sequence of figures. Figure 1 contains 5 line segments. Actually, if you are not sure, count that. 1, 2, 3, 4, and 5. Given that figure n contains 801 line segments, show that n is equal to 200. So we need to check that whether the given sequence is arithmetic, not geometric. So I know clearly from this one, my u1 is equal to 5. Let's calculate second figure. Count the total number of sequences, do not repeat it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Then u3. To check whether the sequence is arithmetic or geometric, you need consecutive 3 terms. Depending upon the 2 terms, you cannot decide whether the sequence is arithmetic or geometric. You require minimum 2 differences. For that you require minimum 3 terms. Now figure 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Check the difference is same or not. 9 minus 5, 4. And again 13 minus 9 is also 4. So yes, it is an arithmetic sequence. They said figure n contains 801 line segment. 801 line segments, that means I know un is equal to 801. So we need to find out which number of term or which number of figure will have 801 line segment. Un arithmetic sequence formula is u1 plus n minus 1 times d is equal to 801. u1 is 5. N we don't know, we will keep it as it is. Difference is 4 is equal to 801. Either you open this, which I will suggest, 5 plus 4 times n is 4n minus 4 is equal to 801. 5 minus 4 is 1 plus 4n is equal to 801. Take 1 on this side, becomes subtraction. So 4n is equal to 801 minus 1, which is 800. Therefore, n is equal to 800 over 4, n is equal to 200, which we need to show. You can see here. Find the total number of line segments in the first 200 figures. Total means sum. So sum, again, you can use first formula, you can use second formula, but I am using second formula because I know first term and I know my 200 term, which is what, 801. So I'm purposely using a short formula. Sn is equal to n over 2 times u1 plus un. So here total number is 200. So 200 over 2, u1 is 5, un is 801, not 200. un is 801. So S200 is equal to 200 divided by 2 is 100 times it is 806. We don't need a calculator. It's simple, straightforward value because last two are 0, so keep 20 here. And 1 you multiply by all three terms, which is 806. So your sum is 80600. That means total number of line segments in the first 200 figures is 80,600. Question number 4. In an arithmetic sequence, first term is 3, second term is 7. Straightforward. u1 is equal to 3, u2 is equal to 7. So difference is equal to 7 minus 3 is equal to 4. Which we have seen similar question here. 8 and 5. Exactly similar question is repeated, only the numbers are changed. Find the 10th term. So un, recall that formula which is given in a formula booklet. You just copy down as it is first. u1 plus n minus 1 times t. So u10 is equal to u1, which is 3, n is 10 minus 1 and difference is 4. So u10 is equal to 3 plus 9 times 4. So u10 is equal to 3 plus 36. So u10 is equal to 39. Last part. Find the sum of first 10 terms of the sequence. Again, I am using the same formula because I know first term, I know last term. Sn is equal to n over 2 times u1 plus un. So S10 is equal to 10 over 2, u1 3, u10 39, 3 plus 39. So S10 is equal to 10 over 2 is 5, 3 plus 39 is 42. So final answer S10 is equal to 5 times 42. 5 times 2 is 10, 5 times 4 is 20, 20 plus 1 is 21. So sum of first 10 terms is 210.